Hello, I am Monda Tutuha and this is my submission for the final year project presentation. My project is based on an investigation on tracking technologies that are used for human chasing robots. So the main goals of my investigation is to firstly write down a report to explain and understand the modern technologies used in human chasing robots. I then need to use that information to help find out and compare the best use of tracking technologies in different scenarios. I then need to find out if there is combinations to help optimize the data captured in real life examples and real life systems. And so some of the objectives that I have designed to help me obtain those goals is to firstly categorize the sensors and technologies on the way they are used in real life. I then need to compare those categories and test how well they do in their scenarios and other scenarios. I then need to design a test where I compare the components and the technical results and data provided by the developers of the actual systems. And so the main purpose and function of my project is to help future researchers on this topic, as well as providing some type of recommendation at the end of the project of what type of autonomous systems to use in what type of scenario. And so to start off, the categorization of autonomous human robots is I basically categorized them into two different scenarios. The first one is the ground scenario, which uses unarmed ground vehicles. An example of that is the Geta cargo robot, which uses multiple sensors like front-facing cameras and Wi-Fi signal to help track and follow around the objects or the humans it is detecting. And so the second scenario is the aerial scenario or UAVs. An example of that is the Digi Mavic Pro, which is a drone that uses RGB data, and then it uses image processing to help follow around a human or an object it is detecting. Then to carry on with categorization, I have designed a flowchart or a table to help explain even more. And so a medium of operation is both scenarios, ground scenario and aerial, and then some of the sensors that I've chosen or used in these scenarios, and then the mode of interaction, and then granularity and degree of autonomy. As you can see, most of the sensors are used in both scenarios, but some are only used in one or the other. And then the mode of interaction is both, it's the same for both, which is explicit and implicit, and that depends on the system or the sensor you are using. And so if some are very implicit, but some are very explicit, and in some combination will result in the implicit one being more explicit. And then the granularity is ground scenarios have a lot of single human, single robot systems, or single human, multiple robots, multiple human, single robots, and that's the same for aerial, as you can have the same thing. And then with the degree of autonomy, most of the ground scenarios are fully autonomous, but that's not the same with the aerial, as a lot of are partial. That's to do with the risk of self-destruction, as there's a higher risk of an aerial system facing a faulty while flying, which will cause destruction. And then to move on into some of the sensors that I have evaluated are front cameras, vertical cameras, RGBD cameras, ultrasonic sensors, infrared and thermal sensors, IMU and GPS. There's a lot of other sensors that I'll be doing in the future. So what I look for is the data they use, and then the challenges and limitations they might face, as well as how they are used or operated. As you can see, most of the cameras use RGB image or RGBD data, depending on what do you use for. And then most of the challenges are to do with lighting or texture as well as sunlight. And to operate them is mostly by computer vision algorithms and other algorithms. And so the data you captured by ultrasonic sensors is distance measured, and then some of the limits is the range you can go by, as some sensors can measure for more than other, depending on how good they are, and they operated by vertical displacement and between two distances. And then infrared will read thermal image, and then IMU will read the IMU data, and then the global or GPS will use a global position, and speed as well as time. And some of the challenges they might face is precision drift, and the refresh rates can differ as well for the GPS, as well as the signal strength and accuracy in indoor settings. So to go into the future works and testing that I will do by the end of this project is to firstly evaluate and compare a lot of more provided data and sensors and explain how they are used, like the previous examples. I then need to choose one or more systems, and I need to get them in real life and evaluate them in depth and see if the data provided is accurate, and see how well they do in multiple scenarios and provide that data within the comparison. And then if I have enough time and enough thing, I might be able to design and build my own prototype from the recommended solutions that I come up with. As you can, and my recommendation will be based on multiple factors. Some will be on the price, some will be on the how effective and accurate they are, and all of this will be put into my final year report. And so that's it for me. Thank you for listening, and